Imagine a vast library stretching beyond the horizon, filled with every book ever written and every book that could possibly exist. Each book contains a different story, a different answer, a different possibility. This is the library of all possibilities, a place where knowledge is infinite, and every secret waits to be discovered. A classical computer is like a diligent librarian, methodically searching through the shelves, determined to find a single hidden phrase among millions of volumes. The librarian checks each book one after another, carefully opening each cover. In a library this immense, the search could take lifetimes, an eternity spent in pursuit of a single answer. Now, picture a quantum computer. It's as if the librarian could split into countless versions of themselves, each searching a different shelf at the same time. Suddenly, every book is read at once and the answer appears instantly. This isn't magic, it's the strange and beautiful world of quantum mechanics, where the rules of reality are written in probabilities, not certainties. Here, particles can be in many places at once and outcomes are never set in stone. Classical computers use bits, ones and zeros to process information, forming the backbone of our digital world. Every website, every app, every message you send is built from this simple language. But some problems are too complex for this black and white logic. They involve countless variables, endless possibilities, and tangled webs of information that would take even the fastest computers years to unravel. Quantum computers don't just follow one path. They explore every possible path at once, harnessing the bizarre rules that govern atoms and particles. They can solve puzzles that would stump any ordinary machine. This is more than just speed, it's a new way of understanding reality itself. Quantum computing opens doors to questions we never thought we could answer. We're stepping from the linear, predictable world of classical computing into the shimmering, multidimensional landscape of the quantum realm, a place where imagination and science meet. The journey is just beginning, promising to reshape everything we know about computation, technology, and even the nature of reality itself. It's not just about making faster computers, it's about building a new tool for exploring the universe, unlocking mysteries from the tiniest particles to the vastness of space. The quantum revolution is here, and it's rewriting the rules of what's possible, inspiring a new era of discovery and innovation. Are you ready to see how deep the rabbit hole goes? The adventure ahead will challenge everything you thought you knew. Let's begin our journey into the quantum world, where the impossible becomes possible, and the future is waiting to be discovered. To truly understand the power and potential of quantum computers, we first need to meet their core building block, the qubit. The qubit is the fundamental unit of quantum information, and it's what sets quantum computers apart from the classical machines we use every day. Unlike a classical bit, which can only ever be a 0 or a 1, like a coin lying flat on heads or tails, a qubit can exist in a superposition, being both 0 and 1 at the same time. Imagine a coin spinning rapidly in the air, not yet decided which side it will land on. That's the magic of a qubit. This phenomenon is called superposition. A qubit doesn't just hold a single value, it holds a blend of possibilities, a spectrum of outcomes all at once, until we measure it. Only then does it settle into a definite state. This isn't just a clever trick, it's a fundamental property of the quantum world. In the realm of the very small, particles don't have fixed positions or states. Instead, they exist in clouds of probability, where anything can happen until we look. To create qubits, scientists harness the strange behaviors of subatomic particles, or use superconducting circuits cooled to near absolute zero. These delicate systems unlock a richer, more complex form of information than the simple on-off switches of classical bits. Here's where things get truly mind-bending. While 8 classical bits can represent just one number out of 256 at any moment, 8 qubits can represent all 256 numbers simultaneously, thanks to superposition. This means quantum computers can process vast amounts of information in parallel. And as you add more qubits, the number of possible states grows exponentially. With each new qubit, the computational power of the system doubles, leading to possibilities that quickly outpace anything a classical computer can achieve. With just a few hundred qubits, a quantum computer could theoretically hold more values at once than there are atoms in the entire observable universe. The scale of this potential is almost unimaginable. This exponential leap in power is what makes quantum computing so revolutionary. It opens doors to solving problems that would take classical computers millions of years. Qubits are the gateway to tackling challenges in cryptography, drug discovery, climate modeling, and optimization, problems far beyond our current technological reach. They're not just a new kind of bit, they represent a whole new dimension of data, a leap into a world where information behaves in ways we're only beginning to understand. The future of computation, innovation, and discovery starts with the qubit. It's the foundation for a new era of technology. The qubit is the key to unlocking the impossible, opening doors to breakthroughs we can only dream of today. Welcome to the quantum era. a time when the boundaries of what's possible are being redefined. Let's dive deeper and see what qubits can truly do for our world. Superposition is one of the most mind-bending concepts in quantum computing. It allows qubits to exist as both 0 and 1, at the same time in a delicate balance of possibilities. This isn't just a theoretical idea, it's a real, measurable phenomenon that sets quantum computers apart from anything that came before. Classical computers are limited by either-or logic. A bit is always 1 or 0, never both. Every calculation is a series of definite steps, like flipping a light switch on or off, with no room for ambiguity. But a qubit is more like a dimmer switch, holding a spectrum of possibilities between on and off, until it's measured. It can represent countless combinations all at once until we peek inside and force it to choose. This is the true power of and, not just or. It's about embracing multiple realities, not being forced to pick just one. Imagine trying to solve a maze. A classical computer would try one path at a time, backtracking when it hits a dead end. But a quantum computer, using superposition, can explore all possible paths simultaneously, as if it's walking down every corridor at once. Superposition enables massive parallelism, letting quantum computers process vast combinations at once. This means they can tackle problems that would take classical computers years or even centuries to solve. Each added qubit doesn't just add a little more power, it doubles the computational space, causing the possibilities to grow exponentially. With just a handful of qubits, the number of potential states becomes astronomical. This isn't just about being faster, it's about a completely new paradigm for tackling complexity. Problems that were once impossible to even attempt become approachable. Quantum algorithms use superposition to perform calculations on countless inputs at once, opening doors to new discoveries in science, medicine, and technology. It's not just like adding more cores to a processor, it's a fundamental leap in parallelism, a shift in how we think about information itself. This is why quantum computers can tackle problems that stump even the fastest supercomputers. Problems like simulating molecules, optimizing complex systems, or cracking codes. From designing revolutionary new materials to breaking cryptographic codes, the power of "and" is changing everything we thought we knew about computing. Superposition is the engine of the quantum revolution, driving us into a future where the impossible becomes possible. It's how we move beyond the limits of classical logic, stepping into a world of infinite potential. The future belongs to those who harness the power of "and", those who dare to imagine, and then build what comes next. The second pillar of quantum power is entanglement, what Einstein called spooky action at a distance. Entangled qubits are linked so that the state of one instantly determines the state of the other, no matter how far apart they are. Imagine two spinning coins. If one lands heads, the other is instantly tails, even if it's on the moon. This isn't communication, it's a unified quantum state. Entanglement lets quantum computers create intricate correlations between qubits, amplifying their power. It's essential for modeling complex systems, like molecules where every electron is connected. Entanglement and superposition together let quantum computers solve problems classical machines can't touch. It's a resource for sharing information and performing calculations in ways we're only beginning to understand. Entanglement opens doors to discoveries we can only dream of. Quantum computing isn't just theory, it's poised to transform medicine, AI, and more. In drug discovery, quantum computers can simulate molecular interactions with perfect accuracy, leading to faster cures and personalized treatments. In AI, they can solve optimization problems exponentially faster, powering smarter, more creative machines. Quantum breakthroughs could revolutionize materials, science, logistics, and climate modeling. Imagine new superconductors, optimized supply chains, and better climate predictions, all powered by quantum. The applications are limitless, touching every field of science and industry. Quantum computing is the master key to the future. The race for quantum supremacy is on, a global competition for technological leadership. Tech giants like Google, IBM, and Microsoft, along with national governments, are investing billions to build the first large-scale quantum computer. Achieving quantum supremacy means solving problems no classical computer can touch, a true Sputnik moment for our era. Nations see quantum tech as a strategic priority, fueling massive investments and new policies. The stakes are high: economic power, scientific breakthroughs, and national security. This race is accelerating innovation at a historic pace. The outcome will shape our world for generations. We're witnessing the dawn of a new technological frontier. Quantum computing threatens the foundation of digital security. Today's encryption relies on problems that are easy to do, but nearly impossible to undo, like factoring huge numbers. A powerful quantum computer could break these codes in moments, making current encryption obsolete. This risk has sparked a race to develop quantum-resistant cryptography, new methods safe from both classical and quantum attacks. The transition will be massive, requiring updates across the global digital infrastructure. Data encrypted today could be stolen and decrypted later, making the urgency real. We're in a high-stakes race: quantum computers versus quantum-safe defenses. The future of digital security hangs in the balance. Will you own a quantum computer? Probably not. These machines are delicate, expensive, and need extreme conditions to operate. Most people will access quantum power through the cloud, sending problems to remote quantum processors. But the impact will be everywhere. New medicines, smarter AI, efficient logistics, and advanced materials, all shaped by quantum breakthroughs. We stand at the dawn of a new computational age, facing both hope and risk. Quantum tech could solve humanity's greatest challenges, or create new ones. The choices we make now will shape the future. It's up to us to guide this technology wisely. The quantum realm is opening. What will we do with it?